Okay, continuing with our discussion of section 2.1, we've got a variety of different equations right here for us to solve in problems 3 through 7. So let's go through and just try some of these out. We're going to take problem number 3 right here. And it says 3 plus x equals 9. What does that mean we do? Well, we have to find a value of x that makes this true. Now, we probably already have an idea what this is, but let's go ahead and use the proper algebraic procedures to illustrate how this is done. If we have a value added to both sides of an equation, we can use the property that tells us that if we add or subtract the same number to both sides of the equation equally, we do not change the solution. We get an equivalent equation. So saying 3 plus x in this equation, if we subtract 3 from the left-hand side and subtract 3 from the right-hand side, we are in effect balancing the equation. And you know, the effect of balancing an equation is one where we keep all the quantities on the same side the same. So what happens is that if we were to take and add or subtract a value to one side, we must add or subtract in exactly the same way to the other. We can't add 3 over here and then subtract 3 over here, or add 3 over here and subtract 3. We would have to subtract 3 in exactly the same way to both sides of the equation to make it equivalent. Well, in this case, we've got 3 plus x minus 3. So if we take 3, take away 3, that just leaves us with x. We get x equals, and then we get 9 minus 3, that gives us 6. Of course, we should make a point that every single time we get a solution, we can check our solution. To check means that we're going to substitute in the value of the variable that we just found to see if it makes the statement true. But of course, we know this is because 3 plus 6 does give us 9. This is a single-step equation. Nonetheless, we're going to go through and use all of our steps to make sure that we are getting the correct answer. All right, let's try it again, this time with problem number 4. This one says y minus 1/4 equals 5/6. Well, again, a little bit more complicated because we are throwing in a fraction in there, and I know that people don't like fractions, but that's all right. We can deal with it. We're taking y minus 1/4, and if I want to isolate y, the way I'm going to isolate y is that if I'm subtracting 1/4 from the left, I want to add 1/4, because we know that a negative 1/4 added to a positive 1/4 gives us a 0. But to balance the equation, if I take 5/6 on the right-hand side, I have to add 1/4 as well. This way I'm adding the same value to both sides to balance the equation. All right, no problem over here on the left. We know y minus 1/4 plus 1/4 is just y. Our real problem is how are we going to add 5, 6, and 1/4? That's right, we need to get a least common denominator. So what is the smallest number that both 6 and 4 will divide into? That's right, 12 is that common denominator. So we rewrite each fraction so that it reflects that. We had to take 6 and multiply by 2. And just like balancing an equation, we have to balance our fraction. So that means we have to make sure that we multiply by 2 in the numerator. That gives us 10. And of course, 1/4. 4 goes into 12 3 times. So we have to multiply a 3 into the numerator as well. 1 times 3 is 3. So our solution comes out to be 10 plus 3 over 12, which is 13/12. When you write a fraction in this class, leave it in the improper form like that. Don't give the mixed fraction of 1 and 1/12. Leave it as 13/12. It's okay to leave a numerator bigger than a denominator. Now, of course, once again, to be sure, we should check. So let's go ahead and do a check right here. We're going to substitute in 13/12 in for y and see whether or not it makes our equation true. We're going to take 13/12, subtract 1/4, and if it worked out correctly, we should end up with 5/6. Well, does that work? Let's see. To subtract 13/12 and 1/4, we need a common denominator. Of course, 4 divides into 12 evenly, as we showed above. So we're going to take 13/12, and we would be subtracting away 3 twelfths, which is the equivalent of 1/4. To see if we get 5/6, 13 twelfths minus 3 twelfths gives us 10 twelfths. And 10 over 12 reduces to give us 5/6, so that makes the equation true. So we've done our job. All right, let's continue on right here. What about this situation, number 5? We have a fraction, -5/8 times x equals 2/5. Well, there's all kinds of ways that we could handle it. We could multiply both sides by 8 in order to get rid of the 8 in the denominator of our fraction. Some people really like doing that. We could divide both sides by 5 because we got 5 in the numerator, and dividing by 5 gets rid of that in the numerator. But the most efficient way is going to be to multiply by something that gives us +1 in front of this fraction. And in this case, that means that if we have a fraction, or a negative fraction, in fact, we're going to take a negative reciprocal of 5/8. So we're going to be multiplying both sides by -8/5. What does that do? Well, -8 over 5 times -5 over 8 is going to give us +1. Right? So we know that's the kind of thing that we want. But of course, to balance our equation, that means we have to multiply both sides by 8/5. So we multiply the left and the right-hand side by the reciprocal. And we're multiplying both sides by a negative so that we get +1 as our coefficient on the left. But what happens on the right here? Remember, we're taking 8/5 times 25. 5 will divide into 25. Right? Remember that if you're multiplying two fractions, we're treating this as 8 over 5. I'll write this off to the side, times 25 over 1. We're treating 25 as the fraction 25 over 1. So we can divide out common factors right here. 5 goes into 25 5 times. So this is equivalent to writing 8 times 5. And of course, the negative sign in front is going to give us, I'll just sort of bubble this in right over here, is going to give us -40. So that's our solution. X equals -40. Of course, again, let's make a habit. Check our work. If we check our work, -5/8 times 40 should give us 25. Well, of course it does, because we know in this one-step equation, if you divide 8 into 40, you get 5. Sorry, -40 right here. That's going to give us the positive 25. Negative times negative, -5, that's 25. That works out, so we're good. All right, one more here. 2 times z equals 0. Well, this one should be pretty clear, but let's go ahead and check it out anyways. If we divide both sides by 2, right? This would be a good case where you're multiplying a whole number times a fraction, so you're multiplying both sides by 2. So you divide both sides by 2. 0 divided by 2 gives us z equals 0. And of course, yeah, that has to be our answer because z is 0. 2 times 0 gives us 0. We're done. One more problem to check right here. Let's take 4y minus 10y and see what value of y gives us -42. Now, this problem seems a little bit more difficult, but really isn't so much. We have to simplify on the left-hand side first. That means we need to combine our like terms. So we're going to simplify by combining 4y minus 10y to give us -6y. As we remember from simplifying our expressions, we combine like terms by combining their coefficients, and we're going to get -6y equals -42. Well, in this case, since we've got a whole number times y, we can simply divide on both sides by -6. Divide on both sides by -6, and we're going to find that y is equal to +7. Does that make sense? Well, of course, we should one more time check by going to the original equation and substituting in the value 7. So we're going to take 4 times 7 minus 10 times 7 to see if we get -42. Well, yes, because 4 times 7 is 28. And if we subtract from that 70, the difference between 70 and 28 is 42, but we're taking this smaller number minus the larger number, so we get -42 equals -42, and that works out just the way we wanted to, and so we're done.